So next we are going to look at electric motor. Okay, when we carry out insulation resistance test on electric motor, what are we actually testing? So if you look at the electric motor, you will see that the electric motor is made up of windings. Okay, and these windings, they are laid in what is called the slot in the stator. Are we getting it? Or the stator yoke, as it's called. Okay, so as you can see on your screen, this is the stator yoke and these are the slots. Okay, so if you look very well, you will see that these windings, these coils, they are not placed directly on the stator. There is an insulation, okay, placed inside the stator before the winding is placed in the slot. Okay, and after placing the winding, another insulator is used to cover the winding within the slot, as you can see. Okay, so this shows clearly that the stator, the winding is separated completely from the stator yoke. Are we getting it? That is separated completely from ground. Then if you also look at these windings, you see that there is an insulation, okay, paper lead thread that is used to separate each of these windings. Are we getting it? So you see that this winding does not have any business or interaction with this winding because of this insulation or this separation. Okay, so the winding that will have interactions are those that you deliberately, on the other side of what you are seeing now, they are deliberately connected to each other or one another, as the case may be. So from what we have explained now, this coil, okay, does not have interaction with ground, okay, and each of the phases of the winding, they don't have interaction with each other. So when you are testing any of the phase, okay, to ground, what you are testing is this insulation or this separation between this winding and ground to see if it is still strong enough, okay, to withstand the pressure that will be on it, that is the voltage pressure, okay, that will be applied to it. Then when you test between lines or between phases, line 1 and line 2, or between U and V, as the case may be, or between U and W, what you are testing is this separation, this insulation of these materials that are used to separate each of the phases. Since they don't have any interaction with each other, of course, you do not expect the insulation resistance to be low. You expect it to be high, depending on the kind of insulating material that is used. Then if you look at this copper conductor, okay, this copper conductor, this winding wire, it is insulated. If you look at it critically, you see that they are coated with varnish. So each strand, as you can see, is insulated from the next strand. Okay, so this will be important when we are doing winding resistance test later. So that is what you'll be testing when you are looking at the electric motor, insulation resistance of the electric motor. So this is the one that has been installed, okay, tied. Okay, so you see these are the insulations separating it from the slot, and also this one is separating each phase, that is this phase from this phase. You can see it. Then this one separating what you see inside the slot, separating the winding from the core. Okay, so what will be exposed to you is not these windings, it will be what you will see at the terminals. Okay, it's like this. So it is either you have the delta connection or the star connection, as you can see. So if you are carrying out insulation resistance tests, okay, between winding and ground, you can actually place it on any of this terminal. Okay, one of the test probe on any of this terminal, and then the other test probe to the ground. that is the frame of the electric motor, and then you get your test voltage. So the reading that you will get is the insulation resistance between the winding and ground. Remember what you are testing. You are testing this separation or this insulation, okay, in the slot that is separating the winding from ground. Are we getting it? Now, if you are testing the insulation between phases, it means that you have to remove these shunting bars on the start point, or these ones that you use to connect your delta. Are we getting it? You remove them so that that will be connection that you can separate them into individual coils. Okay, so W1 and W2 is a single coil, V1 and V2 is a single coil, V1 and U2 is also a single coil. So it is 2 on the other side. So if you test between U1, as this may be, as in this case, U1 and V1, you are testing between the U coil, the insulation between U coil or U winding and V winding. Okay, which means that you are looking at this separation between each of the phase. Okay, since they don't have any business together, you expect to have very high insulation, okay, between the phases. Also, the same thing with power generators too. Okay, power generators, they are somewhat similar to the electric motors. So as you can see, the slots, they are insulated, as you can see. Okay, and even the conductor itself is even insulated. If you look at it critically, the conductor is insulated. And then they are insulated before they are placed into the winding, into the slot. The slot is also insulated. So the rotor also have some windings on them, that is the feed winding. These feed windings, they are also insulated from the core. So they don't have any business with this core. Are we getting it? And so this does not have any business with this core. And this does not have any business with this core. Okay? So remember, we have 3 phases here. Also here, okay, we depends on the number of poles. Okay, here we have about. So this is what you actually see. This is a coupled alternator. That is, this rotor has been coupled into this stator, okay, of the generator. That is what we have here. So what will be exposed to you is the terminal block, not the winding. Okay, when you open the terminal cover, what you have is something like this. Okay, so this is the U phase, V phase, W phase, and this is the neutral. Okay, which means that the start, that is the start point, and this is earth. Okay, from what we saw inside, since it has been started, it means that the 3 windings have been connected to one another. Okay, so you can only take insulation between the winding and ground. Are we getting it? So to do that, you can put one of the probe on any of these terminal, any of these 4 terminal, and then the other probe on this terminal. So when you inject, the insulation resistance you get is the one that is separating the winding from the ground. That is the one that is separating within the slot, the insulation of it. So if any of them is failing on any of the slots, you will see a drop in the, that will cause an increase in leakage current. You see a drop in the insulation reading of the generator. Okay, so this is the connection of what we have here. This neutral point is this. Then we have line 1, line 2, line 3. Okay, the U, V, and W phase. Okay, so this is when it is data connected. Of course, this one is not data connection. Okay, so however the connection that you have in the generator, the terminals that you have here, you can only find insulation resistance to ground, except you have access to open up. Okay, if you can open up and then disconnect the connection point or the start point, then you can test the insulation resistance of each winding. Okay, so if any, maybe you have a drop in your installation resistance value. Okay, you can now go and open up the connection point. Okay, usually they are brought out to the terminal block inside the generator. Then you can disconnect the start point and test each of these windings to ground to know precisely which of the winding is shorted to the ground where you have the problem. Okay, that is that for those three electrical assets or machines. So how significant is the insulation resistance testing? Insulation resistance test is very important because one, apart from helping you to ascertain the reliability of the equipment, that the equipment will function as required without failing. Okay, it also helps to improve the safety of your electrical installation. So poor installation can cause safety issues because poor installation can cause the interaction between live parts and ground, okay, where you do not expect to be live. And once that happens, accidentally anybody touching on that frame, okay, of the equipment, thinking that there is expectedly not there is no current, okay, or no potential at that particular point. Of course, when you touch it, that can result to safety problem or electric shock. Then face-to-face shorting can also result from poor insulation, and the result of that will be fire and explosion. Okay, so the equipment can malfunction and eventually fail once there is insulation failure, drop in insulation value of the equipment. So you see that insulation testing your equipment to get the actual insulation value is very, very important. Okay, to the operation of your electrical asset. So when the insulation is deteriorating, if you are able to detect it on time through your IR test, insulation resistance test, of course that will help you to save all of these situations, because you will take the necessary measures to restore the insulation value back. Some of them is just simply to dry out the equipment, okay, and some energize the equipment without loading them, can just dry out the equipment, or load them lightly, dry out the equipment, and then the equipment will be fit for normal operations again.